In this video, we're going to continue to talk about related rates. Let's take a look at this example. A police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. So here's a police cruiser is going downwards from north, and here's a speeding car, which just turned the corner and heading east. When the cruiser is 0.6 miles north of the intersection, that means y equals 0.6. And the car is 0.8 miles to the east. That means the x will be 0.8. The police determined with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, that means the police car, the cruiser, speed of police car was 60 miles per hour. That means dy dt is negative 60. Be careful, it will be negative 60 because this cruiser was going down towards the intersection. So even though the speed is 60 miles per hour, the velocity is negative. And they want you to find what is the speed of the car. So we have to find the absolute value of dx over dt, which represents the speed of the car. So here are the given information, and we got to find the absolute value of dx over dt. So what is the equation that we need to take the derivative of so that we could use all this information and find dx over dt? Well, look at this triangle. This triangle is a right triangle, and we could use Pythagorean theorem. So z squared equals x squared plus y squared. So let's take the derivative with respect to time. You get 2z dz over dt equals 2x dx over dt plus 2y dy over dt. You have 2 on every term, so you could cancel out the 2, divide each term by 2. And let's plug in the given information. However, how are we going to find the value of z? Only y and x are given, but using Pythagorean theorem, we know that z squared equals x squared plus y squared. So z squared equals 0.6 squared plus 0.8 squared. So you get z squared equals 0.36 plus 0.64, which is going to be 1. And you take the square root, it's going to be positive negative 1. But we don't care about the negative because distance cannot be negative. So z is 1 when y equals 0.6 and x equals 0.8. So 1 times dz over dt is 20. X is 0.8. dx dt is the one that we need to find, plus y 0.6 times dy over dt, which is negative 60. So after you do basic algebra, you're going to get dx over dt is going to be 70. So this means the speed of the car at this moment will be 70 miles per hour. So this car was speeding pretty fast at that moment. Let's take a look at another example. We have water runs into a conical tank at the rate of 9 feet cubed per minute. So you know that this feet cubed per minute has to do with dV over dt, the rate of change of volume respect to time, and that is 9. And since the water is being poured in, you know that the volume is increasing, so dV over dt will be positive. The tank stands point down, which means this point has to be at the bottom, and it has a height of 10 feet, and the base radius is 5. We need to find how fast is the water level rising when the water is 6 feet deep. So we need to find dH over dt, the rate of change of height respect to time, when h is equal to 6. So these are given information, and we need to find dH over dt. Now, using our common sense, since the volume is increasing, the volume of water, that means h has to be increasing as well. Therefore, our answer dH over dt should be positive. So now, what are we going to take the derivative of? We need to take the derivative of volume of a cone, which is V equals 1/3 pi r squared times h. So, but we have a problem here. We have two variables. It's simple when we have one variable instead of two. Now, take a look at these two right triangles. If you remember from geometry, we could use similarity. So R over H. R over H should equal to 5 over 10. So this implies that R is equal to H over 2. Now let's use substitution. Instead of R, let's substitute H over 2. After you simplify, you are going to get V equals pi over 12 H to the third power. Now, make sure that this is in terms of H, because our goal is to find dH over dt. If you wanted to find dR over dt, you probably wanted to write this in terms of R. Now let's take the derivative respect to time. You get dV over dt is pi over 4 h squared dH over dt. Now let's plug in the given information. So this will be 9 equals pi over 4 times h, which is 6, square dH over dt. So now you get 9 equals 9 pi dH over dt. So dH over dt is 1 over pi. So this means the height. At that moment, the height was increasing at 1 over pi feet per minute. Now, another way of doing it is, if you don't want to use a single variable, okay, let's just rewrite this as pi over 3 r squared times h. Let's find the derivative with respect to time using two variables. So it's going to be, pi over 3 is a constant. So it's going to be r squared times dH dt plus h times 2r dr over dt. I got this using product rule. So now, we need to know what dr over dt is and what r is. Well, when h equals 6, remember r equals h over 2? We got that from using these two right triangles. So when h equals 6, that means 6 divided by 2 is 3. So r is 3 when h is equal to 6. What about dr over dt? Well, when you take the derivative of r with respect to time, you get dr over dt. And what's the derivative of that with respect to time? That's 1 over 2 dh over dt. So you know that dr over dt is the same thing as 1 over 2 times dh over dt. So using our substitution now, dv over dt is 9. So pi over 3 times r squared. That's going to be 3 squared, which is 9 dh over dt, plus h is 6 times 2 times 3, which is 6. And then dr over dt is going to be 1 over 2 dh over dt. So this is going to be 18 dh over dt plus 9 dh over dt, which becomes 27 dh over dt, and 27 divided by 3 is 9. So you end up getting 9 pi over 9 pi dh over dt. So just like last time, you get 1 over pi equals dh over dt. So you get the same result. It's just that this method looks more complicated than the other method. But there are two ways of doing this, and you decide which method is easier for you.